Welcome to the course Digital Transformation and Technological Innovation. So, we are into our second module, that is digital infrastructure. So, let us start from where we left in the last session. So, next that we want to talk about in a bit more detail is operating system, right, or OS. So, what is an operating system? So, it is a set of programs designed to control hardware resources and act as an interface with application software, right. So, the main idea behind operating system is to control hardware resources, right, because the applications they would be vying for these hardware resources. To be able to manage those requests, right, operating system act as an interface. So, it acts as an interface with application software, right. So, operating system, as we talked about in the previous sessions, that it is an example of system software, or rather it is the system software, and acts as an interface with application software. And so, main role of operating system is controlling hardware resources, so that applications which might be vying for the same hardware resources, those requests could be managed, and the applications could be executed in a fair manner or real time manner, right. So, now there are multiple scenarios that we can consider under operating system, because there are so many different variants of operating system that can be there, right, and each one of them might cater to different sort of scenarios. So, let us consider them one by one, right. So, one computer scenario, when we are talking about operating system managing one computer, where we have a single user at a time, or it also likely to have one or more processing cores, right. So, in this scenario what we have, operating system would be managing just one computer as a resource, and it will more likely designed to provide or designed to allow interaction from a single user at a time, right. So, more than one user will not be allowed in this kind of scenario, and it might have just one processing core, and single user might be running certain applications. So, one or more processing cores. So, if there are more processing cores, then obviously multitasking can be supported, right, some sort of parallelization, multi-threading can also be supported, right. So, single user at a time, one or more processing core, and we are considering one computer. So, that is one scenario where operating system can be designed to cater to this particular scenario. Then there are other scenarios where we might have to add more functionality to the operating system to be able to cater to those other scenarios. For example, single user OS, right. So, single or multitasking, right. So, essentially in this one you can have examples like Windows 11, that typically goes with a laptop, or iOS on an iPhone. So, here it is only one user that would actually be using this OS. The earlier case, one computer, it was a single user. That means so many different users might be using that one computer. So, that is the scenario that we are talking about, one computer scenario, single user at a time. One user, it could be many different one of those many different users who could be using that computer, and operating system will cater to that scenario. The single user OS is more like a laptop or iPhone, because laptop and iPhone are more likely to be used by a single user that who would be owning single multitasking scenario. Next is one computer, multiple users at the same time. So, earlier we said this scenario was one computer, single user at a time. Now, the next one is one computer, multiple users at the same time. That means operating system for this particular computer should be able to support concurrent users, right. So, multiple users, more than two users, two or more users can at the same time log into that operating system, right. So, it should be able to support, right? One computer supporting multiple users, one computer supporting single user. That means operating system only needs to support one user being logged into the system, right. Next is multi-user OS. So, here we said single user OS, and now we are saying multi-user OS. So, what is the difference? In case of single user OS, it is just the one user who would be accessing, more likely in a case of laptop or iPhone. So Windows 11 IS, they are more catering to this kind of requirement, right, this kind of setting. Now in case of multi-user OS, we might expect that many users can log in simultaneously via different terminals, right. They can use different terminals and connect to that particular computer, and that OS that is there in that particular computer is supporting multi-user scenario. So many users can log in simultaneously via different terminals, right. So then how it facilitates multiple users logging? Techniques like time sharing are used to be able to facilitate. So time sharing, what it does, ensure that tasks don't interfere with each other, right. So through this time sharing mechanism, multi-user OS will be able to support simultaneous login from many users, and they would be logging more likely via different terminals. So what are the examples for this? So you can see Linux, Windows Server. So essentially we are talking about a server computer, and server computers more often than not they are designed to cater to multiple users, and therefore the operating systems would also support multi-user scenario. And Linux and Windows Server or Unix on a server or a mainframe, these are the examples. Essentially when we say multi-user OS, we are talking about a server scenario. The computer is acting as a server and it is supporting multiple users. Multiple users can log in simultaneously via different terminals. So the same computing resources, they would be shared or time shared by these multiple users, right. So now again to summarize, what are the different scenarios that we talked about? So operating system, we said that it is in charge of controlling computing resources, hardware resources, and how different applications will get access to those resources. So it manages that interface, software to software interface that it provides, and sits in between the hardware and the application. So it acts like an intermediary. Now there are 4 scenarios that we talked about. One computer scenario, the single user is there, so that is one kind of setting, and single but that single user can change. It could be that one computer can be shared by multiple people, right. So but at a time one user would be using. Then single user OS, that means that machine, more likely a smartphone or laptop, is being used by just one user, being consumed by just one user. So that is another scenario, right, where Windows 11 and iOS, these kind of OS are more suitable. Then one computer where multiple users might want to log in at the same time, that is another scenario. And then the multi-user OS, right. So many users can log in simultaneously via different terminals, right. So all these scenarios are there, and time sharing techniques like time sharing, they facilitate the multi-user OS and multiple user logging in via different terminals. So moving on, now we talk about the multiple computers and we have multiple users at the same time, right. So there are multiple computers that are involved in this setup, and the operating system should be able to support these multiple computers. So there are more than one computer, so number of hardware resources or computing resources are more than one, and multiple users will obviously be accessing with sufficient computing resources. So the kind of operating system that we are talking about is distributed OS, right. So it connects a network of independent computers and appears as a single powerful system to the end users. So these computers can be connected via a network, dedicated or shared network, and this distributed OS will actually coordinate or connect all these computers, and to the end user it will appear as if it is a single powerful system, but actually it is the distributed OS which is managing many computers, multiple computers, right. So what are the examples for the Solaris on cluster, right, and Fuchsia OS on Google Cloud. So these are some of the examples, right. So now compare what we talked about, distributed OS versus multi-user OS or single user OS. So in distributed OS we have multiple computers and multiple users, and distributed OS is making it look it is presenting it to the end user as one single system, right. So there are many computers involved and then obviously multiple users. Multi-user OS, there is just one computer, but then multiple users, they would be logging in at the same time. This is another scenario. Then the original scenario is that single user OS, and we just have one computer, and a single user would be at a time would be accessing. So it could be Windows 11 on a desktop, or desktop or laptop. So that would be here. Then laptop and iPhone. This is single user OS and all that. So three main scenarios: single user OS, multi-user OS, and distributed OS, right? And catering to different scenarios. So the operating system will have slightly different features to support these different scenarios. Next is embedded OS. Now embedded OS is slightly different and slightly more complex in comparison to what we just discussed. So what is embedded OS? This is a specialized program for microcontrollers and microprocessors, which are embedded in physical devices or equipment. Now day in day out, nowadays most of the modern appliances and equipments that we are using, right, so they have a microcontroller or microprocessor embedded there, and we use those display panels which give us control to manage these appliances and equipments. So these are actually examples of embedded OS. So embedded OS is a specialized program, and for microcontrollers, microprocessors, and these are embedded in physical devices, equipment including AC, refrigerators, and ATMs, and many other such scenario examples. There are lots of examples, and we will talk about that in coming slides. And designed to perform specific dedicated control tasks, because when we say a refrigerator or a washing machine or AC, essentially the main functionality of those equipment or appliances is already understood, and it's just that the microcontroller or microprocessor is playing a role in terms of configuring or doing playing around with the different settings that are supported by the equipment or the appliances, right. So essentially we are talking about dedicated control tasks that are actually supported by this specialized program, which is an embedded operating system, right. So designed to perform specific dedicated control tasks with predictable timely outcomes, right. So you switch on something, you make a change, and you restart the equipment or appliance, you want that particular function to immediately operate, right. So predictable timely outcome. In a general purpose PC and the operating system that might be there, we do certain times certain tasks, and it takes its own time, because the CPU might not be free, CPU might be busy with another process, right. So the task that we are executing, sometimes there is a delay because of the same CPU overworked or busy with other tasks, because those operating systems are designed to be fair, in the sense give sufficient processing to other tasks, or most of the tasks, cover everyone, right. So therefore that predictable timely outcome might not be there, right. But in case of embedded OS, the design is, we are talking about devices and equipment. So the moment you press a particular button or do a particular setting, right, then you expect that to happen. So predictable timely outcomes are to be supported, and obviously you are operating within strict hardware and human constraint, right. So these embedded operating system, they would be running on microcontrollers or microprocessor, which might be just having microchips or smaller capacity chips and little memory and other thing that would be there. So there is strict hardware within that they need to function, and then human constraints are also there. So the human who is interacting with these appliances or these embedded OS on microcontrollers, microprocessors, they might not, they just interact and they just go away, right, and because it's actually an appliance equipment that is being consumed. So the human will also not come there to again interact, right. So that is the kind of setting that we are talking about, right? So embedded OS is very different from what we talked about in a general purpose scenario, whether it is distributed OS or multi-user OS or single user OS, right. So moving on, embedded OS, there are hardware and human constraints. So what are the kind of hardware and human constraint we are talking about here, right. So they run on limited memory, because it's a microcontroller, microprocessor on an appliance, small board that is there. It's a very small board or the control panel that you would see in these appliances. So there is a limited memory, low processing power. So the embedded OS is supposed to be lightweight, right, and there are very few controls that it needs to manage. So limited memory and low processing power, minimal interface. So what you see on the display, that is the the functionality that you can operate, right. So minimal interface and minimal battery use, right, so that you don't have to change the battery again and again, because there is a minimal human intervention angle also. So you don't want human angle to be involved again. So minimal battery use, this embedded OS would be able to function, right. So these are constrained computing scenario, and in these scenarios embedded OS is doing a real time kind of function, not a general purpose operating system function, right. So essentially we can say that it is supposed to be optimized for extreme efficiency, right, extreme efficiency, reliability and speed. So an embedded OS has to work with these kind of constraints. Moving on, now classification of embedded OS. One is let's understand different types of these embedded operating systems. The first one is real time OS or real time operating system, and there are variants within that. It could be a real time operating system or RTOS, industry grade, or it may be a consumer grade, right. So there might be slight differences in these two because there are different kind of devices where they would be operating, right. So in case of industry, RTOS for industry, so it is built for high speed precision, and missing a timely action is considered system failure. So you operated on appliance, equipment or device or machine, so that task or the control that was given, it should work in a expected manner, in a timely manner, otherwise it will be considered failure because the device or equipment might not be able to operate as expected in a normal condition. So therefore because the device and appliances might not operate because real time operating system was not able to support, then it will be considered a failure, right. Now in case of RTOS for consumer devices, so this is built for mainly consumer connectivity, and typically you would see there would be wireless communication to make that connectivity, because there is a portability element, right. There is a portability element that comes with the consumer grade. That means some of these devices consumers might be using directly, and therefore the wireless connectivity might become important. Bluetooth, Zigbee, these are some of the wireless communication protocols which might be used because they are quite good with the ultra low power use, right. So ultra low power use with minimal, because again you want to increase the battery life, you don't want to consumers to change that again and again, right. So built for consumer connectivity via wireless communication Bluetooth. So there are so many devices that we connect via Bluetooth. So the kind of operating system that is there, it is actually RTOS consumer grade, right. So listening a music on some device, and whatever music that you are playing, it should run, right. For example, infotainment system that we have in our cars, right. So this is a real time function should be there, right, and it works with the Bluetooth connectivity. We can connect our smartphones with that, right. So ultra low power use. Then embedded Linux. So there would be certain scenarios where we want slight more processing, so we might need multitasking. So in that case we can we can create stripped down Linux version, lightweight versions or stripped down Linux versions, and they are built for complex multitasking and a bit of more processing power that is needed typically in a multitasking scenario to support some some of these appliances, equipments, devices. So these are three main classification of an embedded OS: RTOS for industry, RTOS for consumer devices, and then the embedded Linux for other complex scenarios. Moving on, now what are the examples of RTOS in case of industry? So there is a free RTOS that is quite popular. Free RTOS is quite common with the smart home sensor IoT devices, right. Then there is QNX that is for industrial uses quite common. For example, automotive infotainment, home hub, right. Home hub where you can manage lots of sensors, cameras through that hub, right. So that is also because this home hub might also be used in hotels and other places, so, and should also have a longer lifespan. This is more of industry grade, right? Then VxWorks, this is mission critical. So now you are sending robots to space or aircraft, generic aircraft that we are talking, right? So there might be mission critical scenarios. These might be fighter aircrafts, right, or rescue or emergency aircrafts. So mission critical scenarios there. So VxWorks is a popular operating system in that category. So you can see we are mentioning popular free RTOS, industrial QNX, mission critical VxWorks. So these kind of different kind of operating system RTOS are catering to these different segments. Then space rovers, aircraft for and control aircraft controls, and then medical imaging. VxWorks is can be used because some of the life where you have to protect a life, those are also mission critical scenarios. So medical imaging is there. Then integrity, this is another RTOS. This is for high security scenario. For example, defense systems, and where you don't want your communication, recorded conversation or other communication to leak. So defense system, airplanes and satellites. So satellite communication, all that. So there you want high security, and integrity is one RTOS that is catering to those scenarios, right? Moving on, for the RTOS for the consumer, what are the example of these operating systems? So we can see G-Fire, for wearables, health monitors, and Tizen RT for smart TVs, smart refrigerators, right? Then Light OS for simple sensors, right? And then we have Windows IoT, that is where digital signage, the different boards that you see and where some content management system is operating and keep on changing what is being displayed on those boards, and other functionality that can be there. So digital signage, medical equipment, ATMs, right? So these are some of the examples where Windows IoT could be common. So RTOS for consumer grade and different examples of those operating system. Moving on, embedded Linux. So what are different examples for this category? So Ubuntu core, where it is common, smart screens, right, and industrial gateways. So right, smart screen, something that we might use in a classroom, and sometimes different functionality that we might need. We might interact indirectly with the screen, and many activities that we can do. Scalability is also an important element here. Smart screens, industrial gateways, right? And Yocto is a another platform where you can come up with your custom tiny Linux versions, and you can tailor them for specific hardware, such as robots that might be used in factory or other settings. And robots can vary. There are so many different kinds of robots can be there, and therefore Yocto provides a platform for the firms to come up with their own custom Linux versions, custom tiny Linux version, which will be tailored to their kind of robot. And OpenWRT, that is for Wi-Fi routers, network gateways that are actually running our network or network of networks. All the routers and gateways that are there, they are likely to use OpenWRT. Then Raspberry Pi OS, that is for Raspberry Pi device, where because this is more for Raspberry Pi boards are more commonly used for prototyping, and therefore multitasking might also be part of something that it could be used for. So therefore an embedded Linux with support for multitasking and therefore needs a bit more processing, so will cater to. So robots, Raspberry boards, Wi-Fi router, network gateways, industrial gateways could be quite complex. Smart screens. So these are some of the examples where you might be better off with the embedded Linux, the stripped down versions of the Linux. Moving on, now few more points about operating systems. So operating system, they play a central role in the functioning of a computer, and typically they would be stored in the primary partition of a disk, whether you are going for SSD or SSD, right? So typically they will be stored here. So when you switch on a computer, what happens? So when you switch on a computer, you start up the boot up process. So we already talked about the bootloader program being another example of a system software. So you switch on a computer, you start up the boot up process, bootloader program, another system software, and the portion of the OS are loaded into memory as and when needed. So the boot up process will start loading the OS, and the key modules, key components of the OS would be loaded first into the memory, and then other will be loaded as needed, right. So this is what happens when we start a computer. So it is the operating system through boot up process that comes up, right. Now, while we talked about that the operating system could be stored in a primary partition of a disk, or simply we can say it could be stored on a disk which is internal to the computer, but externally also we can boot up a particular operating system. So it could be stored on a alternative media options we can use, right. So very common thing we have mentioned that OS is stored on a bootable USB flash drive. So whenever we encounter any issue with our existing laptop or desktop and there is some problem with the OS, it has got corrupted, not functioning well, then we sometimes reinstall or repair that OS. So for that we use an external media, right, which is more often than not a bootable USB flash drive nowadays. So this is another way to boot an operating system. Now, as we already talked about, operating system acts as an intermediary between the application and the hardware, right. So how it does that? So when a request is there, so it converts a request into a set of instructions for the hardware, right. So the hardware, the instruction that it receives, accordingly it will process those instructions. So whenever a request is coming, operating system's role is to convert that in a format which hardware, in a language that hardware can understand, right. So therefore it is playing a perfect intermediary in that case. And what other thing it does, because when a hardware is executing those instructions, right, at times it might have to notify the user for input output attention, because some input might be needed from the user side, or there might be an output that has come and user's attention might be needed. Then there might be errors that might be thrown up, and there might be abnormal events, right. So it will also notify if there is an attention that is needed because of input output operation or errors or events, right. But overall the main idea is that operating system, whenever a request is there to access hardware resources, computing resources, operating system will convert that request into a set of instructions that are understandable by the hardware, right. So let's stop at this point and we'll continue this discussion in the next session. Thank you.